So once again, the F statistic is basically, if you look at the graph, the variance between the groups, which is the treatment effect. You want that to be large. You want whatever your treatment is to really have an impact over the variance within the groups, which is when all people got the drug, you wanted them to be about the same. You know, this situation actually, if you were to look at it, 5, 6, 7, and 1, 2, 3, sums of squares within group would be what? 1, 2, 3, 5, 6, 7, 2 for each one. So 2 plus 2 is 4. How many people do you have in the first group? 3. So it's 2 again, 2 again. The variance within group here would be a 1. So it'd be significant again. And if you did an ANOVA or an F test, the final point I want to make, if you actually did this as an ANOVA, the graph, if you want to write it down, the F score for this situation would be a 24. The F score, sorry, I've been doing this too long. Not enough brain damage to correct this knowledge and information. The F score would be 24. If you go back in your notes and look at this example from the last class, I think we did this example in the last class, didn't we? 1, 2, and 3, and 5, 6, and 7?
I wasn't here, I don't know.
Does anybody have that from the last class?
I do, but I have to dig it out.
That's okay. The T-score. The T-score that we got was 4.899. Maybe write that down. How would he know that? Good thing the car didn't roll over 2 times. I was in a little...
What was it again? 4.89?
899. The T-score was 4.899. The F-score is 24. Do you think there's any relationship between T-scores and F-scores? As I said, you could do either a T-score or an F-score.
There better be then.
There better be then. With ANOVAs, what do we do with everything? We square it. Anybody got a calculator? 4.899.
Well, it would be close because 5 times 5 is 25.
So 4.899 equals, yep, you're right. Sorry.
24.00201.
T squared equals F. T squared equals F. So if you do a 1-factor ANOVA with 2 levels or a t-test, T squared equals F.
Could you go backwards? Could you present all of that and look like a statistically versatile person?
So
that's just redundancy.
The big thing is the probability. The probability would be the same. If you did the t-test on this, well, it's not this example, it would be the same significance level. And that's what matters. So these would both, with the memory data here, it's actually, the p-value is a James Bond movie. Where's she going with that one?
007?
It's 00. That was very good. I like that.
I know my movies.
The p-value. Sorry, I've been doing this for...
Where we put our time.
It was so funny when I had my bike accident all those years ago. I had to get my job back, and I almost did not because I couldn't remember. Short-term memory was affected. It was poor before that, but I was able to help somebody do statistics and stuff, and all of the stuff that I'm chatting to you, you can tell it's not short-term memory. It's actually just log jumped up there in my brain, and it was like, I think he can still teach, even though he can't remember 15 people's names if we give them back to him back and forth. So, with that said, we'll stop. That was a brief recording. Yeah, we'll make that.